You reach for a steel axe, a saw, or a power drill, and every tooth and edge does exactly what you expect. Now take away the metal, the hardware shop, and even the idea of a manufactured blade. How did ancient humans cut wood without metal? The answer begins with a surprise. They did not simply batter trees with crude rocks. They understood wood, selected specialized stone edges, and combined cutting with splitting, scraping, abrasion, and sometimes fire. Modern tools encourage you to think that sharpness belongs to metal, but a freshly fractured stone can be astonishingly sharp. Flint, chert, obsidian, quartzite, and other knappable rocks break with edges thin enough to slice flesh and plant fibers. Those edges are brittle, however. Strike them carelessly into a trunk and they chip. Ancient woodworkers therefore needed more than sharp stone. They needed the correct edge angle, the correct motion, and the correct piece of wood. Technique mattered. What would you choose if you had to cut a branch right now? Green wood is usually easier to chop and carve than seasoned wood because its fibers are moist and comparatively flexible. Species matter too. Oak resists differently from pine, yew, spruce, or willow. Prehistoric people did not need modern botanical textbooks to notice those differences. Repeated work taught them which trees split cleanly, which bent into handles, and which produced straight shafts. That knowledge survives indirectly in the wood they selected. Unlike your hardware store axe, the earliest woodworking tool might have been nothing more than a heavy stone flake held directly in the hand. Its maker struck a stone core to detach an edge, then used that edge to score, shave, and chop. Microscopic polish, edge damage, and trapped residues can reveal this work. Archaeologists compare ancient ware with experimentally used tools, although interpretations are not always certain. Stone that worked wood develops different patterns from stone used on hide or bone. But could handheld flakes produce serious objects? At Schöningen in Germany, waterlogged sediments preserved wooden spears dating to roughly 300,000 years ago, along with other worked wooden implements. Their makers, generally associated with early Neanderthals or related humans, shaped long spruce and pine trunks into balanced hunting weapons. The surfaces show careful trimming, and the densest part of the wood was positioned to strengthen the point. You are not looking at accidental sticks. You are looking at planned engineering. Modern wood normally rots, which creates a vast blind spot in the archaeological record. Stone survives almost everywhere. A wooden handle usually disappears. That imbalance can make the Stone Age look as if it contained only stone. At Clacton-on-Sea in England, however, part of a sharpened yew implement survived from around 400,000 years ago. At Kalembo Falls in Zambia, waterlogged deposits preserved two large logs joined by a cut notch about 476,000 years ago. The exact purpose remains debated, but deliberate woodworking does not. How do you fell something larger than a spear shaft? You do not need to slice straight through a trunk as a modern saw does. With a stone axe, you chop a ring of angled blows, knocking out chips and gradually creating a V-shaped cut. Experimental archaeology shows that reconstructed stone axes can fell surprisingly large trees, though more slowly than steel axes and with repeated edge maintenance. The worker changes position, reads the grain, and lets the trunk's own weight finish the fall. Slow is not helpless. A modern axe arrives as one object. A prehistoric axe had to be assembled. A shaped stone head could be fixed into a wooden handle directly, inserted into an antler sleeve, or bound against a haft. Rawhide, sinew, plant cordage, resin, and tar could secure the joint, depending on period and region. Birch bark tar is known from Middle Paleolithic contexts and is often associated with Neanderthals, though scholars debate exactly how some early tar was produced. Hafting transformed a sharp rock into a force multiplier. Why add a handle at all? Swinging a hafted axe increases speed and concentrates energy at the edge while keeping your hands away from the impact. Yet the head does not need to be razor thin. Many later prehistoric axes were ground and polished, producing tough, regular edges less likely to crumble during repeated blows. Grinding could take hours. You rub the shaped blank against abrasive stone with water and sand, checking the angle again and again. The result is durable. That changes everything. Modern carpentry separates axes, chisels, planes, wedges, and adzes into labeled tools, But ancient workers could create the same actions with stone, bone, antler, and wood. An adze has its edge set across the handle, making it useful for hollowing trunks or flattening surfaces. Wedges driven into existing cracks split timber along the grain. Small flakes shave rough areas. Burins and pointed tools cut grooves. You do not defeat every fiber individually. Whenever possible, you persuade the grain to separate itself. Could fire replace an axe? Sometimes, but not by simply setting a tree ablaze and hoping. Controlled charring softens and weakens a limited area, which can then be scraped away with stone. Repeated burning and scraping can help hollow a log into a container or canoe, and ethnographic examples show how carefully the fire must be managed. Wet clay, damp vegetation, or water can protect surfaces that must remain intact. Archaeological burning is difficult to interpret, however, so fire should be treated as one method, not the universal answer. Where can you actually see sophisticated carpentry without metal? Early Neolithic wells in Central Europe provide remarkable evidence. Waterlogged wells associated with linear pottery communities, including examples from Ythra and Altscherbitz in Germany dating to the 6th millennium BC, preserved split oak timbers assembled with carefully cut joints. Builders used stone adzes and axes to make planks, notches, and fitted corners. Some trees were felled centuries before bronze became common there. Their joints show planning precise enough to survive underground for 7,000 years. Unlike a modern sawmill, these communities often made boards by splitting rather than sawing. You begin with a straight trunk, open a crack using wedges, then drive additional wedges along its length. If the grain cooperates, the tree divides into long slabs with far less labor than chopping away all the intervening wood. Those slabs can be trimmed with adzes. The Sweet Track, built across wetlands in southwestern Britain in 3807 or 3806 BC, used worked oak planks and supporting poles produced through such skilled timber conversion. But how did they keep stone edges working through an entire project? They resharpened them. Flaked edges could be retouched by removing tiny fragments. Ground axes could be returned to an abrasive surface. Broken heads might be reshaped into smaller tools. The process demanded time, so communities also sought dependable stone sources and exchanged high-quality material across considerable distances. In Neolithic Europe, axes made from distinctive alpine jadeite traveled hundreds of kilometers. Some were practical tools, while exceptionally polished examples probably also carried social or ceremonial value. You can now see why without metal does not mean without technology. Technology is not a material. It is an organized way of solving a problem. Ancient people combined knowledge of tree species, season, moisture, grain direction, stone fracture, leverage, adhesives, and edge repair. Metal eventually made many operations faster and allowed thinner, more resilient blades, but it did not invent woodworking. When the first copper and bronze axes appeared, they entered a world already filled with houses, platforms, handles, vessels, trackways, and weapons, made by accomplished woodworkers. So what really cut the wood? Sometimes it was a flint edge, sometimes a ground axe, a stone adze, an antler wedge, abrasive sand, or a carefully controlled ember. More often, it was the sequence that mattered: score, chop, split, scrape, grind, and repeat. The missing ingredient was never intelligence. Most of the wooden world has simply decayed, leaving stone tools as quiet evidence of hands that once turned whole trees into useful forms. Comment with the method that surprised you most, and subscribe for more archaeology hidden by decay.